Greetings and welcome to the Algorithmic Design with Grasshopper webinar. Algorithms are an integral part of working with Grasshopper, but how you approach their use will dramatically alter your creative process. This webinar will focus on creating algorithms using lists and transformations in Grasshopper, iteratively developing geometries inspired by nature. Through a series of short presentations and live case studies, you will learn strategies that will allow you to discover forms that are defined by simple rules and incremental creation. So I'm Gil Akos.
I'm Ronnie Parsons.
And we are Mode Collective. Mode is a multidisciplinary design collective located in Brooklyn, New York. We have three interrelated sub-entities, Lateral, Design, and Lab, through which we offer fabrication and consulting services, design services, and we also, through Mode Collective, have a lab, which is our share source initiative, consisting of a web repository for learning resources related to design and technology, including a series of monthly webinars and bi-monthly workshops that are hosted here in our studio. So here's the website for Mode Lab. You've all been here. This is how you registered for the webinar. But this is the location for finding all of the learning resources related to design and technology, frequently related to making and digital fabrication. So all of the previous webinars can actually be found here through the Learning Videos category through the navigation menu. And if you haven't seen some of the results of our workshops recently, you can also find that on Mode Lab or through our Facebook page. So this is an example of one of the workshops we conducted called Lattice Lab. We were looking at topological modeling and 3D printing. So we were looking at simple primitives that we could then smooth to create more intricate geometries and work very iteratively through moving from Grasshopper through 3D printed prototypes and back again. So the workshop's really a way for us in an intensive environment over a couple of days to investigate a particular topic with a diverse set of individuals that come to learn about that topic. That's really exciting for us. So as I mentioned before, you can also connect to us and your fellow Mode Labbers through our Facebook page, which is at this URL here, facebook.com/Mode Collective. And really, this is the way to find out the most current and up-to-date information related to learning content, upcoming events, etc. So if you haven't already, we'd love it if you could connect with us on Facebook. Okay, so let's get on to the webinar content. What exactly are we going to cover today? So the topics for today's webinar are, what's an algorithm and how do I define one? And if you have some experience using Grasshopper, you might have a question such as, isn't Grasshopper already a graphical algorithm editor? And how is algorithmic design different from parametric design? And how does that fit into the paradigm of Grasshopper? What is the difference between incremental versus all-at-once execution? And what creative opportunities does each provide? And we'll be spending a lot of time talking about this particular set of topics, because really that's the key to thinking algorithmically, thinking parametrically, and what the differences are and kind of creative frictions that might emerge from either of those approaches. And lastly, I have a few simple transformations within my sketch. How can I compound them to discover new forms? So defining things very simply, and then layering them up so that we can discover the kind of aggregate or cumulative result. It's really interesting stuff for today. Okay, so a couple of notes before we get started about the webinar administration. We're going to be covering all of these topics over the course of the next 2.5 hours. That's going to include a question and answer session after each exercise that we go over. The whole course will be recorded and distributed later online. You'll get a series, you'll have access to a series of shorter videos to come back and reference at your leisure in the future. And you also receive all of the instructor files that we create together when we do the exercises. So Ronnie and I will be conducting the webinar simultaneously. I'll be running the exercises and presentation for the first half of the webinar, and Ronnie's going to take the second half. And the person who's not presenting is going to be monitoring any questions you might have. So make sure that you feel confident that you can, in the question window, write us a message whenever you have a question, technical or otherwise. And any of the consistent questions we get will be redirected to the presenter, and Ronnie and I will have a conversation with you about what the opportunities are to answer those questions. And the idea here is that we really want to create, as much as possible in the webinar format, a live and interactive experience for you. Okay, so the name of the webinar is Algorithmic Design Grasshopper, so we need to take a brief moment to talk about what Grasshopper is. Okay, Grasshopper is a node-based algorithm editor integrated with Rhino 3D's modeling tools. So it's a plugin for Rhino, and it allows us to, visual context, define and edit algorithms. Okay, so the great thing about Grasshopper is that it's really easy to use. There's a kind of minimal overhead in terms of just getting started with it. Because it's visual, we can connect objects together to start to define relationships, and then kind of see what the result of those relationships are. But really, particularly with the approach we're going to be using today, thinking about things in terms of algorithms, we're going to stress the fact that it's an algorithm editor and what that means as we work with Grasshopper. So as we work with Grasshopper, we're going to be defining logical relationships between design parameters that will subsequently define a parametric model, right? And that's just a model wherein the parts of the design relate and change in a coordinated way. And that's as defined by the parameters and dependencies stated, and those parameters and dependencies are stated by you, which is really important. All right, so here's an example of a sketch that could be, that we can kind of examine for how it is constructed as a parametric model. Right? We have four diagrammatic plan profiles that together create a kind of massing that can be sliced up into different layers, right? So if it's a parametric model and it's defined by the parameters and dependencies stated, let's unpack that a little bit. A parameter in the most general sense is any factor that helps define the limits and performance of a system. So if we have, again, that same set of planimetric profiles, here we have a series of parameters, radius 1, radius 2, length 1, length 2, length 3. Those values, which in this case we see the current state of, R1 being 1.12. Here we have another state of the exact same profile, but in this case the parameters have changed. Now these are only two states. The parameters are showing us the result of all of the relationships as defined by the particular values for each parameter. But what we don't see here is that R1 has a limit that is has a minimum and a maximum, right? In this case, we only see two states. So really, it's all the possibilities in between the extremes that parameter is allowed to be defined as. And so here's a close-up of that diagram. All right, so what that means is that when we're working with a parametric model, right, we have to understand how data flows through the set of relationships that we establish. Typically, we're going to divide things into manageable parts. It's going to require that we think abstractly instead of, let's say, concretely or tactilely as we model something manually in Rhino or another CAD environment. Whenever we're working with relationships and logic, it's going to require that we think abstractly. We're also going to have to start thinking and using our mathematical knowledge, right? Numerical values, expressions, functions, etc. All that stuff's going to come into play as we work within a parametric environment. And lastly, and maybe most importantly, or at least where the most opportunity is and where we can have the most power in using a design tool such as Grasshopper is that it can allow us to be very fluid in how we think algorithmically. So, what's an algorithm? An algorithm is just a set of rules that precisely define a sequence of operations. So again, if we're thinking back about to this set of profile curves that are defined by the 5 parameters that we see here, right? The set of operations would be something like define a length away from a center, that's L1, define a radius moving from that point on that line. The 2 opposite points of that circle are going to be anchor points for part of the profile curve. You keep building from there, right? So to arrive at this profile, there's going to be many operations that are happening in combination to allow us to have a coordinated profile despite the change in model parameters, right? So again, if we think about what that means for what the algorithm is, at the basic kind of essential level, it has 3 elements: input, processing, and output. In the case of the profile curve, the processing, there's quite a bit of it, right? But that doesn't mean that that an algorithm has to be complicated or complex. It just means that the processing part is more kind of robust or functional, or has been developed more at least, right? So any algorithm is going to have these 3 elements, and that's all really that we need to define an algorithm. So if we take a very simple example, if we have an addition operation, we're going to add 15 and 10. That's going to result in 25. Now this is maybe an oversimplification. Addition is an algorithm. It's a very simple one. But here we have indication of how Grasshopper works in terms of it being node-based. We draw connections to define the inputs of an object. Something happens, and then we get an output. Okay, so the same thing would happen if we were to think about creating geometry and not just working with numbers. If we have 2 points, right, point A and point B, we can draw a line between them. In this case, the algorithm is only to draw a line. Okay, so we understand that algorithms are defined by input, processing, and output, right? The processing is the set of either single or sequential operations that are defined, so that's what will occur. And we know that the processing part can be thought of as a very simple rule, or it could be something that's more layered or complex. Okay, so what does that mean? If we have a comfortable understanding of what an algorithm is, how might we actually structure it? Should it be we do step A, then step B, then step C? Or do the result of A and B define C, etc., right? So how we structure it exactly is going to change exactly how we're working with the data coming in and what we want, how we want it to come out, right? Also, we want to be conscious of where we're placing control, right? Do we want to define everything at first, or do we want to build up a series of operations incrementally so that we have control over each step? And lastly, does it solve all at once, like in a split second everything calculates, or does it work incrementally, right? Again, this is kind of another way to say what we were talking about at point number 2 here. But in terms of Grasshopper, because it's a visual programming environment and allows us to edit algorithms, right? It wants to calculate all at once. But exactly how we use it is going to determine whether or not we're asking for it to do that, or kind of slow down a second and build up more incrementally what we are defining as our algorithm.